Hello everyone. Today we will learn about matrices, which is basically Unit 3 of NCERT for class 12th CBSE and other board students. So let's begin. So first of all, what we are going to cover in this video. So we are going to cover what is a matrix, the definition of a matrix, what is the order of a matrix, types of matrices, and equality of matrices. So first of all, what is a matrix? A matrix is an ordered rectangular array of numbers and functions. So let's say if I have some information, and how would I represent that information in the form of a matrix? So let's say you have two students, Ram and Sham, and Ram has, let's say, two pens and three pencils, and let's say we have Sham who has four pens and five pencils. So how we are going to represent this information in the form of a matrix? So first of all, for any matrix we have to put these brackets. You can see here that these are the rows. So this is row 1 of the matrix, this is row 2 of the matrix, and these are the columns of the matrix. So this is column 1 of the matrix and this is column 2 of the matrix. Okay, so like this, any matrix can have multiple rows and columns. For example, here I have shown you two rows and two columns of the matrix. Okay, so row can represent any variable and columns can also represent any variable. Like in this particular case, I can showcase that pens are represented in the rows. I'm going to represent the pens that Ram has or Sham has in the form of a rows. So let's say this particular row is for pens, and this particular row is for pencils. Okay, and this column is representing the information for, let's say, Ram, and this column is representing the information for Sham. So you can observe that Ram has two pens, so I'm going to fill in 2 here, and Ram has 3 pencils. Similarly, Sham has 4 pens and 5 pencils. So this particular row is for pencils, this particular row, like this one, is for pens, this row is for pencils, right? And this is for Ram information, and this column is giving me Sham information, right? So that's how we can fill in the given information, the numbers or functions in a particular matrix. Secondly, the elements that you are observing here, elements as in the numbers, basically these 2, 4 are known as the elements of a matrix, or you can say the entries of the matrix. Okay, so 2, 4, 3 and 5 are known as the elements or the entries of a matrix. Okay, so next is the order of a matrix. So what is an order of a matrix? So let me give you an example. Suppose we have a matrix having elements 2, 3, 4, 5, 6, 7. So clearly this particular matrix has two rows. This is row 1 and this is row 2, and 3 columns. This is column 1, column 2 and column 3. So we have to write the order of the matrix at the bottom right of these brackets. So clearly, first of all, we have to write the number of rows, which are 2 here, times the number of columns, which are 3 here. So this particular matrix is of the order 2 times 3. Every time you have any matrix, you have to write the order of the matrix, and order of the matrix will be given by number of rows times the number of columns. Let me give you another example. This time I'm taking 2, 4, 5, 6. In this particular matrix, you can observe there are 2 rows, R1 and R2, and 2 columns as well, C1 and C2. So the order of this matrix is going to be 2 by 2. Another example is given in figure 1, which is having, there is a matrix having an order of m times n, which means there are m number of rows and n number of columns. Clearly, A11, A12, A13, these are the elements basically of this particular matrix. A11 means this particular element is in the first row of the first column. Similarly, if I have to write A23, what is A23? A23 is an element of a matrix which is located in row 2 and column 3. You can observe this is row 2 and column 3. So this is an element A23. So like this, any matrix can also be represented in this particular format. Ij representing the row and the j representing the column, and m times n representing the order of that particular matrix. Next, you should know that any point can also be represented by a matrix. So let me take any point P having coordinates 2, 3. So I can represent it like this. Suppose this first row is representing the x coordinate of the point and the second row representing the y coordinate of the point. So I can write 2 and 3 here. I can also represent this point like this, where the first column is representing the x coordinate and second column representing the y coordinate. So I can also represent this point as like this in a particular matrix. The only difference is that of the order of the matrix. Here you have 2 rows and 1 column, so it's a 2 by 1 matrix, and here I have 2 columns but 1 row, so it is going to be 1 by 2 matrix. Both the matrices are obviously representing this point P only. So like this, you can have a square which obviously has 4 vertices. So let's say this is 1, 0, right, and this is 3, 0, right, this is going to be 1, 5, right, and let's say this point is nothing but 3, 5, right. Let's say this is point A, this is point B, this is point C, and this is point D. And if I have to represent these 4 points in a particular matrix, okay, so how would I represent it? So there are 4 points, right? 4 points, and each point has 2 coordinates, x and y coordinate. So I can assume ki, okay, this is point A, first row is going to represent point A, second row is going to represent point B, then point C and point D. And first column is going to represent the x coordinate and second column is going to represent the y coordinate of that point. So point A has 1, 0, so x coordinate is 1, y coordinate is 0. B point has x coordinate of 3, y coordinate of 0. C point has x coordinate of 3, y coordinate of 5. And point D has x coordinate of 1 and y coordinate of 5. So this is going to be the matrix, right? I can, for again make the brackets to make it clear for you, like this, okay? And the order of this matrix would be what? There are 4 rows, 1, 2nd, 3rd, 4. 4 rows are there and 2 columns, so 4 by 2. So it's a 4 by 2 matrix. Let's look into an example. So here they have given you consider the following information regarding the number of boys and girls students in 3 class sections 1, 2 and 3. Represent the above information in the form of a 3 by 2 matrix. So it's very easy. We have to represent this information in the form of a 3 by 2 matrix. 3 by 2 matrix means there are going to be 3 rows and 2 columns. So I can represent class section 1 information in row 1, class section 2 information in row 2, and class section 3 information in row 3. And I can assume that first column is giving me the information about the number of boys and second column is giving me the information about the number of girls. So in class section 1 there were 30 boys and 25 girls. Then there were 25 boys and 31 girls in class section 2, and then there were 27 boys and 26 girls in class section 3. So this is the matrix of the order 3 by 2. Again they are asking what does the entry in the third row and second column represent. So they are talking about this particular entry, third row and second column. So this represent what? The number of girls basically, right, in class section 3, right? So we are getting the information about the number of girls in class section 3 of the school. We are getting this information from this particular element, right? Then we have another example. Construct a 3 by 2 matrix whose elements are given by, so they have given you a general formula to write the elements. So if I have to develop a 3 by 2 matrix, I need 3 rows. So 3 rows and 2 columns, right? So first row is going to have a11 element, right, and a12 element. Since there are 2 columns, so a11 and a12, right, this is going to be row 1. Then a21 element and a22 element. Why? 21 means second row and first column, and a22 means second row and second column, and finally I'm going to have a31 and a32 element. Why I'm getting this? Let me extend the brackets so that you get the clarity. So these are going to be the elements of this matrix: a11, 12, 21, 22, 31, 32, right? Now if I have to find the elements, I have to use this particular formula aij, where ij would take the value of 11, 12, 21, 22, 31 and 32. So let's begin with a11. For a11, I is 1 and j is 1, so I can write it is going to be I is equal to 1 and j is also equal to 1, right? So this is going to be what? Half mod of 1 minus 3, right? Which is what? Half of 1 minus 3 is what? Mod of minus 2. Mod of minus 2 is 2 only. So the first element is going to be 1, right? Similarly, I can write a12. For a12, I is 1 and j is 2, right? So half mod of 1 minus 6, right? So this is going to be what? Half of 5, mod of negative 5 or just 5, so which is going to be 5 by 2. Then a21, so half I is 2 basically, so 2 minus 3, this is basically half of, 2 minus 3 is negative 1, mod of negative 1 is just 1, so it is going to be 1 by 2 only. And then a22 is half I is 2 and j is also 2, so that is going to be half of mod of negative 4, which is nothing but 2 only. And then I can take a31 element, which is half mod of 3 minus 3, which is nothing but 0, and a32 element, which is half of 3 minus 6, which is negative 3 by 2 or just 3 by 2, right? So I have got all the elements using this particular formula given to me. I can just fill in the elements in the given matrix, right? So I have 1, a11 is 1, a12 is 5 over 2, a21 is 1 over 2, a22 is 2, a31 is 0, and a32 is 3 over 2. So this is going to be the matrix of the order 3 rows were there and 2 columns, 3 by 2 matrix. Understood? The next is the types of matrices. So we have certain types of matrices. The first being the column matrix. So what is a column matrix? A matrix is said to be a column matrix if it has only one column. So let me give you an example. Suppose I'm writing a matrix 2, 3, 4. You can see this particular matrix has 3 rows in it, right? and just one column. So this is a column matrix, and what is going to be the order of this matrix? 3 times 1. Therefore, in general, any column matrix can be represented Aij m times 1, where m could be any number, any natural number, and but column would be just 1. So this is a column matrix. Then we have a row matrix. A matrix is said to be a row matrix if it has only one row. So let me give you an example. 2, 3, 4. Here you can see there is just one row. However, we have multiple columns C1, C2 and C3. So the order of this matrix is going to be 1 times 3. So in general, we can represent any row matrix as Bij 1 time n. You can see n could be any natural number based on the number of columns, but number of rows would always be 1. So this is a row matrix. Next is square matrix. So any matrix in which the number of rows are equal to the number of columns is said to be a square matrix. So let me give you an example. Suppose I am writing 2, 3, 4, 5. So here we have two rows R1 and R2, and we have two columns C1 and C2. So two rows, two columns. So this is going to be a square matrix, right? So like this, I can give you another example as well. So let's say 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we have three rows. This is row 1, this is row 2, this is row 3. And we have three columns. This is column 1, this is column 2, this is column 3. So this is a matrix of the order 3 times 3. Clearly your number of rows and number of columns are equal, therefore it is a square matrix. Okay, so the only condition for a matrix to be a square matrix is that the number of rows must be equal to the number of columns. Okay, and then a special note that any square matrix of order n, then elements would be A11, A12, A33 are known as the diagonal elements, right? So like in this particular matrix, A equals to 1, -3, 1, 2, 4, -1, 3, 5, 6. You have the diagonal elements as 1, 4 and 6. These are the diagonal elements. So if you have any square matrix, a 3 by 3 matrix or a 2 by 2 matrix. 3 by 3 matrix example is already given. Let me draw an example of a 2 by 2 matrix, 2, 3, 4 and 5. So the elements A11, A22, A33 like this, these are the diagonal elements. So here the diagonal elements are going to be A112 and A22, which is 5, right? So for any square matrix, the elements A11, A22, A33, A44 and so on and so forth are termed as the diagonal elements or elements at the of the diagonal. Okay. Then we have a diagonal matrix. So a square matrix. So diagonal matrix is always a square matrix. So a square matrix is said to be a diagonal matrix if all its non-diagonal elements. So what do they mean by non-diagonal elements? Non-diagonal elements need to be 0 in a diagonal matrix. So let me give you an example. Suppose you have a 3 by 3 square matrix and we have the diagonal elements as 1, 2 and 3. So these are A11, A22 and A33 element. What about the remaining elements? Remaining elements has to be 0. So non-diagonal elements have to be 0. So this is basically your diagonal matrix where non-diagonal elements are 0, and at the along the diagonal of the matrix all non-diagonal elements have to be 0, and along the diagonal all the diagonal elements have to be non-zero. Okay, so you can see that you have a diagonal matrix over here and Bij means any element when I is not equal to j, which means they are talking about the non-diagonal elements, they have to be 0. Next, now we have a scalar matrix. So scalar matrix is nothing but a diagonal matrix only. What was diagonal matrix? Diagonal matrix was a matrix where elements on like non-diagonal elements were 0. In a diagonal matrix, non-diagonal elements were 0. So any diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. So earlier I gave you an example where the diagonal elements were 1, 2 and 3 and non-diagonal elements were 0 since it was a diagonal matrix. But this diagonal matrix would become scalar matrix if all the diagonal elements are equal. Let's say 1, 1 or 1, right? Or you can say 2, 2 and 2. Okay, let me change it. 2, 2 or 2 or 3, 3 or 3. So you can say this is a scalar matrix. Why? Because all the diagonal elements are equal. So this is a scalar matrix. So non-diagonal elements have to be 0 and the diagonal elements have to be equal to some constant. In this case, it's k. So Bij, any element, has to be equal to some constant k when I and j are equal, but when I and j are not equal, the element has to be 0. So this is a scalar matrix. And then we have identity matrix. Identity matrix is again a square matrix, right, in which elements in the diagonal, which means they are talking about the diagonal matrix, right, diagonal elements, diagonal matrix are all 1 and rest are all 0. So like, what was the diagonal matrix first of all? So in diagonal matrix, all non-diagonal elements have to be 0. So I quoted you an example of 1, 2, 3, 0, 0, 0, 0, 0, 0. This was a square matrix of the order 3 by 3. Also, this square matrix was the diagonal matrix. Why? Because all the elements at the diagonal were non-zero, right? Then this diagonal matrix, so this is basically a diagonal matrix. This diagonal matrix becomes a scalar matrix when all the elements at the diagonal on the diagonal are equal. So we took an example of 2, 2, 2 and all non-diagonal elements have to be 0. And this diagonal matrix becomes scalar matrix and this scalar matrix would become identity matrix if all the elements on the diagonal are equal to 1. So 1, 1, 1. So 0, 0, 0, 0, 0, 0. So this becomes an identity matrix. So any identity matrix by default is a scalar matrix. All scalar matrices are not identity matrices. The reason is for a scalar matrix to be an identity matrix, the elements on the diagonal has to be 1. So all identity matrices are scalar matrices, but all scalar matrices are not identity matrices, right? Both scalar and identity matrices are diagonal matrices and they are square matrices by default. Okay, and then we have a zero matrix. Zero or a null matrix, we call any matrix as a zero or a null matrix if all its elements are 0. All elements are 0. So 0, 0, 0, 0, 0, 0, 0, 0, 0, or if a 2 by 2 matrix 0, 0. So it's a null matrix. We generally represent it by O or simply O. So it's a null or a zero matrix. Next is equality of matrices. So two matrices A and B would be equal if they have the same order. So if one matrix is of the order 2 by 2 or 2 by 3 or 3 by 3, the other matrix B has to be of the same order, right? And second condition for equality of matrices is that each element of A is equal to the corresponding element of B, right? That is, Aij should be equal to Bij for all I and j. So let me give you an example. Suppose you have 2, 3, 4 and 5. So it's a 2 by 2 matrix, and this is matrix A, let's say, and we have another matrix B. Both matrices must be equal if the second matrix is also of the order 2 by 2 and all the corresponding elements. Corresponding element means if A11 element is 2, your A11 element of the second matrix has to be 2, right? A12 element has to be 3. A21 element has to be 4. Corresponding element must be equal, and A22 element has to be 5. So these two matrices are equal. Next, we have an example here where two matrices are given and these two matrices are equal to each other, and we have to find the values of A, B, C, X, Y and Z. So if you guys remember, for two matrices to be equal, their order has to be equal. So you can see both the matrices are of the order 3 by 3, and each corresponding element of matrix A has to be equal to the corresponding element of matrix B. So can I say X plus 4, which is basically A11 element, has to be equal to 1, right? Similarly, can I say Z plus 5 is equal to 7, right? And can I say this element, which is basically A23 element, has to be equal to 2C plus 2? So I can write 2C plus 2 is equal to 0, right? Can I say B minus 3 has to be equal to 2B plus 4? 2B plus 4 is equal to B minus 3, right? Can I say this A minus 1 has to be equal to minus 3? Because the two matrices are equal. Can I say 2y minus 7 is equal to 3y minus 2? So like this, each corresponding element has to be equal, and using that I can find all the unknowns. So like here x plus 4 is 1, so I can say x is equal to negative 3. Here I can say z is equal to 2. Here I can say c is equal to negative 1, right? Here using this I can say b is equal to negative 3, negative 4 is negative 7, right? And then here it is a equals to negative 3 plus 1, it's negative 2, and here it is going to be a negative 7 plus 2 equals to y. So y is going to be negative 5. So I got all the values: x negative 3, z2, c negative 1, b negative 7, a negative 2 and y negative 5. That's all. So I hope you enjoyed the video and you understood whatever I was trying to convey you. So for more such videos, do not forget to subscribe our channel. Thank you very much.